Number 4, we're solving a triangle using that law of sines that we had before that said sine of A over A equals sine of angle B over B equals sine of angle C over C. However, in this case, we are going to have ones where we have two sides and an angle, side-side angle. And when we have a situation like that, we could just have one triangle that works, we might have two triangles that work, or we might have no triangles that work. So before I go about doing all my solving, we need a few notes about how do I figure out, do I have one triangle, no triangles, or two triangles? So, first thing they're going to have you do is find what they call H. H is equal to the side adjacent to the angle, which is next to the angle, times the sine of your angle. So, in this case, I'm going to look at this triangle here and say, okay, I have side A is 29, side C is 11, and my angle that I have is 66. So, the side adjacent to my angle is 11, then I'm going to take it times the sine of my angle. So, H is going to equal 11 times the sine of 66. Again, I want to make sure my calculator is in degree mode, but if I do that, 11 times the sine of 66 gives me 10.049. So now what I'm going to do to check is I'm going to say, okay, if H is equal to the opposite side, or the opposite side is greater than my adjacent side, I'm going to have one triangle. So in this case, H isn't equal to the opposite side. It's not 29. Is my opposite side greater than my adjacent side? Well, my opposite side is 29. It is greater than my adjacent side. So on this one, I'm going to only end up with one triangle. I'm going to put my little note there. Now, that one fit the first situation. We were good, but I'm going to finish my notes here about how many triangles I have. So one triangle if H equals the opposite side, or if the opposite side is greater than my adjacent side, which in this case it was. If my opposite side is less than my adjacent side, and H is greater than my opposite side. So if my opposite is less than my adjacent and H is greater than the opposite, then we're going to have no triangles. If my opposite side is greater than my adjacent side and H is less than the opposite side, which is less than the adjacent side, then I end up having two triangles that work. So, take a minute, jot down those notes, because you're going to need to find out how many triangles you're going to have. 1, 2, 3, 4, no. 0, 1, or 2 are your only choices. So in this case, we've already figured it out. H was not equal to the opposite side, but the opposite side is greater than the adjacent side. We're going to have only one set of answers. So, we're going to use our law of sines in order to figure this out, or at least start with that. We know that if we take the sine of 66 over A, 29, so sine of angle A over side A, it's going to equal the sine of C over 11, since I have side C. Cross multiplying here, this would be times this to get the C by itself, and so I'm going to say 11 sine of 66 over 29 equals the sine of C, and so on our calculator we're going to do the inverse sine. The inverse sine of 11 sine sine of 66 over 29. You may or may not need the parentheses depending on your calculator. I like to put the parentheses there just in case because it doesn't hurt and I know it's going to work out better that way. So, inverse sine, you're going to use shift sine. You should see sine to the negative 1. In parentheses, I'm going to do 11 sine of 66. And you can just use divided instead of the fraction, or you can use the fraction. I'm going to use divided. So 11 sine of 66 divided by 29, close my parentheses, hit equals. I get 20.27444. I am rounding my answers again to the nearest tenth. So, angle C is going to be 20.3 degrees because I'm going to round that off to the nearest tenth. So, C is going to be 20.3 degrees. Now, we have angle A, we have angle C. Easy enough to find angle B because for angle B we just have to subtract. For angle B, we're going to take 180 minus our 66 minus our 20.3. So, 180 minus 66 minus 20.3 gives me 93.7. So, B is 93.7 degrees. So, we have angles A, B, and C. We have side A and C. We still need side B. Again, to avoid rounding issues, use the original information you had. So in this case, I'm going to use the sine of 66 over 29 equals the sine, and angle B was 93.7 over B then. Solving that by cross multiplying, I'm going to take the 29 times the sine of 93.7. I'm going to end up dividing by the sine of 66, like I did on problems 1, 2, and 3. And I'm going to punch that into my calculator. So 29 sine of 93.7 divided by the sine of 66 gives me 31.678. Again, I'm rounding to the nearest tenth, so side B is going to be 31.7. Now I have all of my angles and all of my sides of my triangle found. Again, I'm not going to write this part down every time. Make sure you have those in your notes because you're going to want to check and find out do you have one triangle, no triangle, or two triangles? So I'm going to keep my paper with my note handy. So, on this one, we know that B is 35, A is 64, and angle B is 109. First thing we're going to do is figure out what H is. So we said to find H, we're going to take the side adjacent to my angle, which is going to be the 64, times the sine of my angle 109. So, 64 sine of 109 gives me 60.513. So we checked with our rules. It said, is H equal to my opposite side? This time my opposite, the opposite of my angle is 35. Well, H is not equal to 35. So then we said, okay, is the opposite side greater than the adjacent side? Well, the opposite side is 35 and the adjacent side is 64. So no, the opposite is not greater than that one. So I know that I don't have one triangle. So I go down to the next one. Is the opposite side less than the adjacent? Yes, 35 is less than 64. And is H greater than the opposite? So H is 60.513. Is that greater than the opposite side of 35? Yes. So we got that the opposite side was less than the adjacent side. H is greater than the opposite side. We're going to end up with no triangles, so we are going to say no solution. Hey, that was a quick one because it followed the test. If I follow my test, I'm not going to have any triangles that work, so I have no solution. So, number 6, same kind of thing. I'm going to start by finding H. First, I better label my triangle so I know what I have. Consider the triangle ABC. Suppose that side B is 30, side A is 35, angle B is 34. So the adjacent side is 35 times the sine of 34 would give me H. The adjacent side times the sine of my angle. So 35 times the sine of 34 gives me 19.57. So now we check. Is H equal to the opposite side? The opposite side is 30. Well, nope, it's not equal to that. Is the opposite side greater than the adjacent side? My opposite side is 30, my adjacent is 35, so no. The opposite side is not greater than the adjacent side, so we know we don't have one triangle. So we check the next part. Is the opposite side less than the adjacent side? Yes. The opposite is less than the adjacent. Is H greater than the opposite? No, H is not greater than the opposite. 19 is not greater than 30. So we know we don't have 0 triangles, which probably means we have 2 triangles, but we'll look at our test. Is the opposite side greater than the adjacent side? The opposite side I think I wrote that down wrong. Is the opposite side should be less than the adjacent side. So is my opposite side less than the adjacent side? Yes, 30 is less than 35. And is H less than the opposite side, which is less than the adjacent side? So H is 19.57. Is that less than 30, which is less than 35? Yes. So we have 2 triangles. So fix your notes because I think I wrote that down wrong. At least I wrote it down wrong on my paper. I should have said, is the opposite side less than the adjacent side? And H is less than the opposite, which is less than the adjacent. Then you get 2 triangles. So go back, fix that on your notes. I better fix it on my notes. All right, so in this case, H is less than the opposite, which is less than the adjacent. I'm going to end up with 2 sets of answers. Hopefully I left myself enough room to write. So, starting this one off, we are going to use our law of sines. Finding my pen here. I have angle B and side B. So I'm going to use the sine of 34 over 30 equals, and I have side A. So I'm going to use the sine of A over the 35. I'm going to solve that. So cross multiplying. Since this is under here, I'm going to take 35 times the sine of 34 and divide it by 30. That's equal to the sine of A. And so in order to figure that out, we have to do the inverse sine of our 35 sine of 34 over 30. So inverse sine parentheses 35 times the sine of 34 divided by 30, close my parentheses, gives me 40.722. So rounding that off, I would have 40.7. So A is going to equal 40.7 degrees. Now that's for one of my triangles if A is an acute angle. If A happens to be the obtuse angle, what I'm going to do for my other angle A is to take 180 and subtract the 40.7. If it's obtuse instead of acute, making a straight line across here, I would take 180 minus 40.7. So 180 minus 40.7 gives me 139.3. So I'm going to have a second set of answers. 139.3 is going to be my other answer for angle A, because I'm going to have two different triangles. So from there, I knew that this is 34, this is either 40.7 or 139.3, so I can find angle C by subtracting. So both of these I'm going to find angle C. The first one I'm going to take 180 minus my 34 and minus my 40.7. So 180 minus 34 minus 40.7 gives me 105.3. So here angle C would have to be 105.3. If angle A was my obtuse angle, I would take 180 minus my 34 minus my 139.3, using 139.3 for angle A. So 180 minus 34 minus 139.3 gives me 6.7. So if angle A is my obtuse angle, then angle C will be my acute angle. And so either angle A is 40.7 degrees, which leaves angle C being 105.3 degrees, or angle A is 139.3 and angle C is 6.7 degrees. Now, we found side A, or angle A and angle C. We still have to find side C. So in order to find side C, we're going to use the law of sines on both of these two things. So the given one was the sine of 34 over 30. Sine of 34 over 30 is going to equal side C, which would be the sine of 105.3 over C. So solving that one, when I cross multiply, I'm going to take 30 sine of 105.3 divided by the sine of 34. 30 sine of 105.3 divided by, whoops, that looks weird, 30 sine of 105.3 divided by the sine of 34 gives me 51.747. Why that didn't come out right. I came up with a rounding error. The reason I got a rounding error is because I used the rounded off angle here. If I would read my directions, it says to carry your intermediate computations to 4 decimal places, so that when you're doing your calculation, instead of using the rounded off answers up here, I have to use my answer, and I should have carried it to 4 decimal places. So that should have been 40.7. There was another 2 on the end of that. So I have to make sure here I use the 40.7 222. So now I got to resubtract here. So for angle C, I'm going to have 180 minus 34 minus 40.7222. And so this would have been 105.2778, carrying it to 4 decimal places. So when I did my problem over here, I should have used 105.2778 instead of using the 105.3. So now if I recalculate that using the 0.2778, 30 times the sine of 105.2778 divided by the sine of 34. Now I'm getting 51.752. And so when I round that off to the nearest tenth, I get 51.8. So a good lesson to be learned there is when it tells you to carry your computations to 4 decimal places, make sure you do that when you're doing your work, because if I use my rounded off answer, even though that's what the answer is I'm going to enter in, I get a little bit of rounding issues. And so I would have put in 51.7. It would have said I was wrong because it really should have been 51.8 because of the rounding. So we still need to find C over here. The same kind of thing holds true. Here, trying to figure, oh, there we go. When I did this one, I should have carried this out. And so I would have had 180 minus 40.7222, which means I would have used 139.2778. So over here, I would have used 139.2778. And so 180 minus 34 minus 139.2778 gives me 6.7222. So when I do my law of sines, like I did over here, I'm going to use the 6.7222 and make sure I carry it to 4 decimal places. So again, my law of sines, I'm going to take my sine of 34 over 30 equals the sine of 6.7222 over C. So when we solve that, we would take 30 times the sine of 6.7222 divided by the sine of 34. So 30, excuse me, times the sine of 6.7222 divided by the sine of 34 gives me 6.279. 6.279 rounds off to 6.3. So I am going to enter in my answer with 2 sets of answers. Either angle A is 40, which makes angle C 105.3 and side C 51.8, or angle A is 139.3, angle C is 6.7, and C is 6.3. So, moral of the story here is carry your computations out to 4 decimal places, because when you're doing this last part where you're using the law of sines, your angles can't be rounded off too far, or you may get incorrect answers due to rounding.